Means we have wrapped up chapter 2. So next week you're going to want to bring any questions you have on the online homework or any questions. There's a review button. I think there's a review posted, so you can click on that and ask any questions you have about the review for the test, which will be later in the week. So let's go ahead and get started. The first question says, what is the tangent to a curve and when the curve is a circle? And so you might remember from your studies of geometry that if you have a circle, the tangent line just kisses the circle at one point. Okay, just at one point it kisses or touches the circle. And so if this is the center of the circle, say O, it comes out at this point P, and it is tangent. And this L could be our tangent line. And it does turn out that the radii to the tangent is perpendicular. That's something you use in a physics or Cal 3 class. It is kind of an interesting thing, not something we're going to talk about here too much. So we do know that L passes, the line L passes through P perpendicular to the line from P to the center O. We know that the tangent line intersects the circle at one point. So it intersects at one point. And we also know that it just hits it on one side. Okay, so that's this idea of tangent line. You may also remember the idea of a secant line, right? A secant line would intersect the circle in two places. So really the concept of calculus is to imagine, because we really want to know the slope of the tangent line. That's what we're always looking for. And so what we do is we imagine a secant line, and what we do is we reduce the distance between these 2 points so it gets closer and closer to becoming a tangent line. And then you can approximate the slope of the tangent line by finding the slope of the secant line as the distance between the 2 points on your curve goes to 0. That's that whole limit as h goes to 0 thing. So in general, tangency for a general curve, if you have just a function, you know, and we talked about continuity and nice smooth functions. That's what we want to deal with for a little while here. The tangent line at a given point is going to be just right where it kisses the curve at any particular point. So if this is the point P with the x-coordinate x, you know, that line right there is the tangent line. Here, you can say the slope of the tangent line, or the tangent line is right there at that point. This could be another x. So here you can see that the rate of change of the line is negative, where here, and the equation too is we say it's decreasing, and we can see that the tangent line is negative. Did y'all see that? And here you see that the function is increasing and the tangent line is positive. So that's something that we will use later as we try to graph more complicated curves in, you know, the world before graphing calculators. Okay. So what are the definitions for slope of a curve and tangent line to a curve? Well, you know this from days gone by, perhaps, and I've kind of showed it to you before, but it's worth talking about again. A lot of it is just notation. Say we have some function or some curve like this, and we're going to choose to find the secant line between the point x sub 0, that's our starting point, x naught, our initial point. Then we're going to go some distance. What do you think that distance is going to be?
X1.
Well, normally h. Do you remember h is kind of the distance? I was just testing. I'm sorry. So this is x naught plus h. Does that make sense? So yeah, we're at x naught and then x naught plus h, which could be x1 and x2. Just we're trying to, be as most confusing as possible with our notation, okay? So this is my function f. So this y coordinate right here is what? What is that y coordinate right there? How would I describe it in terms of x naught and f? It is f of x naught. Do y'all agree with that? That this point right here is the point f of x naught. I mean, that's the coordinate. So this point right here, this point is the point x naught, comma, f at x naught. So the most general way I describe that point. Are y'all with me? Okay. So in the same logic, I can come up here and I can find this coordinate, right? And the y coordinate there is going to be f of x naught plus h, right? So in general, this point is the point x naught plus h, comma, f of x naught plus h. So the starting value plus a little bit, and then the y value at that starting value plus a little bit. That's what x naught plus h means. Okay. Then, of course, we're going to draw the secant line in between those two points, and we could call, let's go ahead and label these points. We'll label them. This one's going to be Q, this one's going to be P. Okay, and so we can say that the secant line PQ has a slope of, let's see, well, the formula for slope is change in y over change in x. x2 minus x1 over, I'm sorry, y2 minus y1 over x2 minus x1. So in this case, it's going to be f of x sub 0 plus h minus f of x sub 0 all over x sub 0 plus h minus x, right? And then that will clean up a little bit, and that will clean up to be f of x sub 0 plus h, x naught plus h, minus f of x naught all over h, right?
Would you repeat those? Would it be minus x naught?
Thank you. Yes, x naught. Okay, and so that's all over h. All right? That is a function that you probably have seen in college algebra, f of x plus h minus f of x over h. That's called the difference quotient. You practiced it a lot. You have practiced it a lot. And so this is the big day where if we make the distance, if we take the limit now as h goes to 0 of this function, we will get what we call the slope of the tangent line. This gives us the slope of the tangent line. Because as we make this distance smaller and smaller, we're going to get closer and closer to the approximation of the slope at x naught. Or yeah, definitely at x naught, but also we can do this in general and get a function. We won't do that yet, but we can get a function for the slope of the tangent line, and so then we can plug in any x. We don't just have to put x naught in specifically. Okay, but right now we're saying in our examples we'll have the point, we'll want to know the slope of the tangent line at 3, and so we'll put 3 in for x naught. But later you can find the slope of the tangent line at x. And what you'll get is a function, and then you can pick any x and plug that into the function and get the slope at that point. Does that make sense? Okay. It's kind of semantics. All right. And of course, if the limit exists. And we talked about when the limit exists quite a bit, you have to, from the left and the right, get the same value and that sort of thing. Okay. So what are the steps to find the tangent to the curve y equals f of x at the point x naught, y naught? So they're giving us a specific point, like they'll say when x equals 2. They might give us when at the point 2, 5. But if they give us the x and they give us the function, we can find the y just by plugging it in, right? So that's not a problem. The first thing that you would do then is to calculate f of x naught, which they may have given you because it is just y naught. Calculate f of x naught and f of x naught plus h. That's the first thing you're going to do. Then you are going to calculate the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. You're going to get a number. And then finally, if the limit exists, the equation of the tangent line is, this is exactly your slope. So in your algebra classes, since the beginning of time, you've been asked to find the equation of the line, right? And the equation of the line, you need two things. You need a slope and a point to get the equation of a line, right? And so you have a point. You have the point x naught, y naught, and you just found the slope. This is the first new way to find the slope. You used to have to do change in y over change in x, or maybe be given information that the two lines were parallel or something like that. Now you have a new thing, finding the slope using this limit formula. And if the limit exists, the equation at the tangent line is y minus y naught equals m onto x minus x naught. Okay? So these are kind of fun. You're going to learn shortcuts in the next chapter, but don't, you don't want to learn them yet. You want to enjoy the algebra. You want to be the algebra, feel the algebra. Okay, so y'all ready to, oh, it looks like Robinson might be checking in. Hello? Not yet. Okay, so if we want to find the equation line for the tangent of the curve y equals 4 minus x squared at the point negative 1, 3, and then sketch the curve and tangent together, okay? All right, so they gave us f of x, right? F of x is exactly 4 minus x squared, okay? They told us x naught is what? That's the negative 1. That's this point right here. That's my x naught. This is my y naught, also known as f of x naught, right? Okay, and we see that f of x naught is f of negative 1, which was given to be 3, or you can stick negative 1 in there, and you see 4 minus 1, negative 1 squared is in fact 3, okay? All right, and so now you need to calculate f of x naught plus h. All right, so you're going to do 4 minus, oh, okay, sorry, hold on a second. We know x naught is negative 1, so we're going to do f of negative 1 plus h. Y'all okay? Okay, sorry. And so then we're going to do 4 minus negative 1 plus h quantity squared. And we will simplify this a little bit. This is going to be 4 minus negative 1 plus h squared, remember, is negative 1 plus h times negative 1 plus h. I'm going to try and show as many steps as possible on this problem, but at any point, if you want to cut, you can. All right, so then this is 4 minus negative 1 times negative 1 is 1. Negative 1 times negative h is minus h times negative 1 is minus h times h is h squared. And so then this is 4 minus 1 minus 2h plus h squared. There's probably a day where you can jump from this step to that step. Hopefully that day has occurred. Okay, and then this is distributing the negative 4 minus 1 plus 2h minus h squared. So this that we have just found is the equation for f of x naught plus h. Okay? And we also know the equation for f of x naught. It is, or the value for f of x naught, it is 3. So we are ready to use our limit to work this problem and try and find the slope at the point. So the formula is that the limit as h goes to 0 of f of x naught plus h, which in this case is negative 1 plus h, minus f of x naught, which is negative f of negative 1 all over h. And so f of negative 1 plus h we found to be 4 minus 1 plus 2h minus h squared. So this is going to be the limit as h goes to 0 of 4 minus, for some reason this keeps coming up on my computer, sorry, 4 minus 1 plus 2h minus h squared. That's your f of negative 1 plus h. Then you're going to subtract f of negative 1, which is 3, and you're going to divide that all by h. Everyone okay? Now, if you have done this correctly, what happened? What should happen? Everything that doesn't have an h in it should cancel out in the numerator. So 4 minus 1 minus 3, those cancel, right? And so you do just have 2h minus h squared over h. Now, if you do a direct plug-in, you get 0 over 0. But you can see that if you factor the h out, you would be okay. So if we do the limit as h goes to 0, we have h parenthesis 2 minus h over h. Our h's cancel. Now we can do a plug-in, and we get 2 minus h. As h goes to 0, it's just going to be 2. Okay, so this is my slope of the tangent line. All right, and we have, and that's at the point negative 1, 3. Okay? And so your equation of your tangent line is y minus y1 equals m onto x minus x1. So in this case, it's going to be y minus 3 equals 2 onto x minus negative 1. And cleaning that up, you get y equals 2x, that's going to be plus 5, because it's going to be plus 2, and then you move the 3 over. Okay? So what does that mean graphically? Well, if you graph the function 4 minus x squared, that's just going to be a parabola that is shifted up 4 units and reflected across the, reflected across the y-axis and then shifted up 4 units. X-axis, reflected across the x-axis and then shifted up 4 units. And then if you graph the line 2x plus 5, and I can do this in the standard window, you can see that we actually do have a point of tangency at that negative 1, 3, and that's that line. Okay, so we found the equation of the tangent line, or we actually found the equation of the line at that point. Is that fun? Yes, Mrs. Brooks, that's so rockin' awesome. So we'll pop that right there. It's gonna look cool. Maybe that's Robinson.
Do you have a that like tease your hair with? Okay, thank you.
Oh my goodness. What are we doing? Are we cooking up the something?
Grilling
Grill the goats.
Grilling the goats.
Yes.
All right. Okay, we are here. We've already started. So you guys, I hope maybe you came in and have already looked. I'll do a quick review real quick as you come in. So get your stuff out. Let's go. I'll be fast. You can watch it on the video though. Okay, what we talked about at the beginning today was this idea of a tangent line. When you have a circle, a tangent line is just where it kisses the circle in one place, and it is perpendicular to the center, which in a later class does become important, especially when you're talking about velocities and acceleration and such. We talk about tangency in terms of a curve by just picking a point and then trying to draw the tangent line right at that curve. And the slope of the tangent line actually tells you about the behavior of the function. Here you see the slope is negative, the function is decreasing. Here you see the slope is positive, the function is increasing. Okay, so that's this idea of a tangent line. All right, this is kind of scary, but it's just notation. If you're at a point x naught, then the y-coordinate would be f of x naught. Then if you go h away, you will then be at the point x naught plus h, and the y-coordinate would be f of x naught plus h. So you have 2 points. You have the point P, which has coordinates x naught, f of x naught, and the point Q, which has the coordinate x naught plus h, comma, f of x naught plus h. So the whole idea of finding the slope of the tangent line is that we will let h go to 0, and we'll get Q closer and closer to P. We'll take the limit to where we can find the instantaneous rate of change at that instant of x naught. So if we think of P and Q as what we call the secant line, we can find its slope as just the change in y over the change in x. So if y for point Q is f of x naught plus h, that's y for point Q, minus y for point P, which is f of x naught, all over the difference in the x's, which does just turn out to be h. They are h apart. This is the difference quotient, which you should have seen in your pre-calculus class or a college algebra class. F of x naught plus h minus f of x naught all over h. You may have seen it with an a or an x plus h, f of x plus h, without the x naught. The x naught here in this section is just actually telling you it's a specific point, like 2 or 7 or 12. When you just talk about f of x, that's when you'll get a function that is what's called the derivative, which gives you the slope of the tangent line at any point. But right now we're going to be specific in particular points, and so that's why we have the x naught there. Okay, so if you can find this limit, it will be exactly the slope of the tangent line at the point x naught. And so the steps to find the tangent line are to first figure out f of x naught and f of x naught plus h, then to calculate the limit, which will give you the slope. And then the way you write the equation of a line, I like to use the point slope formula. But if you like to use y equals mx plus b, that's fine as well. So we came in and we did number 5. We did example 5. We were told that we have an equation for the tangent at the curve. Find the equation for the tangent of the curve, y equals 4 minus x squared at the point negative 1, 3. So you recognize that this negative 1 in the problem is your x naught, and the 3 is your f of x naught, or your y naught, okay? So x naught is negative 1, f of x naught is 3. You'll put the negative 1 in for x naught to find f of x naught plus h. That's really looking for f of negative 1 plus h. So we just did a little bit of algebra here, because it would be 4 minus negative 1 plus h squared. And we got f of negative 1 plus h to be 4 minus 1 plus 2h minus h squared. So we took that and plugged it in there. Then we plugged the y value at negative 1 in for f of negative 1. So that was 3. And then we compute this, and we found the limit, and that limit gives us the slope. Then once we know the slope, we have the point negative 1, 3, and so we're back in Algebra 1 where we just write the equation of the line. And I graphed on my calculator the curve 4 minus x squared minus 4, and then this line 2x plus 5, and you can see that at the coordinate negative 1, 3, you do have this tangent line there, okay? And you would say that the function at negative 1 is increasing, and you see that the slope is 2, so you can kind of have a sense of how it's increasing, right? How much it's increasing. If you had a slope of 5, it would be increasing faster than if it were a slope of 2. If you have a slope of 1/3, it would be slower, right? If you have a slope of 0, that's actually really exciting, because if you have a slope of 0, you have what's called a horizontal tangent line, which means you will learn means you have either a max or a min. at that point, which is very important. Like if you're launching something and you don't want to hit the building or whatever, you want to know how high it's going to go. Okay, so we'll do another problem that to help you guys understand this. So this is just another problem. This is number 6. All right, it says find an equation for the tangent of the curve y equals 2 square roots of x at the point 1, 2, and then sketch the curve and the tangent together. Okay, so this 1, 2 is your x naught and your f of x naught. Now sometimes they may just give you x naught, and you can always find f of x naught by plugging x naught in. So you could plug 1 in here, and you find that you do get 2 when you do 2 times the square root of 1, which is just 2. Okay? So in step 1, the first thing you want to do is calculate f of x naught, which is to calculate f of 1, which is already given to you to be 2. But you could plug it in to find it if you wanted. Then you want to find f of x naught plus h, which is f of 1 plus h, in this case, because your x naught is 1. And so here that's going to be 2 on the square root of 1 plus h, because that's what you plug in for x in the function. All right, now we're going to calculate the limit. So we're going to look at the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. So for our problem, it's going to be the limit as h goes to 0 of 2 on the square root of 1 plus h minus 2 all over h. Everybody okay? All right, so now we're back in the sections where we're doing limit problems, maybe like 2, 2. The problem when you try to do a direct plug-in is that you get 0 over 0. If you plug 0 in for h, you're going to get 2 minus 2 over 0. So that's 0 over 0. So you need to use some algebra to clean this up. What would be the algebraic technique that we would use? Yeah, we'll multiply by 1 in a mysterious form. In this case, the conjugate. We'll multiply top and bottom by 2 square roots 1 plus h plus 2 over 2 square roots 1 plus h plus 2. Everybody okay? Because when we did the direct plug-in, we got 0 over 0. So we knew we need to do a little bit of work on the problem. Okay, now you'll FOIL or clean this part up, and so you'll get the limit as h goes to 0 of, this will be 4 times 1 plus h, and the middle terms fall out because that's the whole beauty of it, and then it's going to be minus 4 all over, this is going to be h times 2 square roots 1 plus h plus 2. So this is the limit as h goes to 0 of 4 plus 4h minus 4 over h times 2 plus the square root of 1 plus h plus 2. So this is the limit as h goes to 0. 4 minus 4, those cancel. So you get 4h over h times 2 on the square root of 1 plus h plus 2. Everybody okay? Now you should see what happens. The h's cancel, and you can do a plug-in. And when you do the direct plug-in, plugging in 0 for h, you get 4 over 2 plus 2. 4 over 4, which is 1. So this is 4 over 2 square roots 1 plus 0 plus 2. 4 over 4, which is equal to 1. That is what? No, it is your slope, right? That is equal to your slope. All right, so now, what do you have? The whole question is find an equation for the tangent line, right? So you have a slope, you have a point, you're in Algebra 1. If you have a point and you have a slope, the equation of the line is just, I like to use point-slope formula, but you can use y equals mx plus b if you want. So you do y minus y1 equals m onto x minus x1. Is that messing you up because I had x naught and y naught? Now I have x1 and y1. It doesn't matter. Letters don't matter in math, right? It could be I could have used x1 and y1 if I wanted right there. So this is y minus 2 equals 1 times x minus 1. And so finally, cleaning that up, you get, if I distribute and move the 2 over, y equals x plus 1. Okay, number 7 says, find an equation for the tangent to the curve y equals x cubed at the point -2, -8, then sketch the curve and the tangent together. Okay, so same problem. Our function is x cubed now. So f of x naught, or sorry, what is x naught? Yeah, x naught is -2. F of x naught means f at -2, which here is -8. F of x naught plus h means f of -2 plus h, which is going to be -2 plus h cubed. All right, and so we got to cube that bad boy out. You guys remember the binomial theorem, binomial expansion for this, or? Yeah, okay. So this means -2 plus h times -2 plus h times -2 plus h. So if you multiply this all out, here you can just FOIL that part. So that's going to be 4 minus 4h plus h squared times -2 plus h. And then distributing, and let's see, so this is going to be -8 plus 8h minus 2h squared plus 4h minus 4h squared plus h cubed. So this is going to be -8 plus 12h minus 6h squared plus h cubed. Okay, so we'll look at the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. That's asking for the limit as h goes to 0 of f of -2 plus h minus f of -2 all over h. All right? Well, the limit as h goes to 0 of f of -2 plus h is all of this stuff right here, which is -8 plus 12h minus 6h squared plus h cubed. And that's your f of -2 plus h. F of -2 is -8, and that's all going to be divided by h. So just a bunch of algebra. Okay, when you clean this up, you have -8 plus 8, so those cancel, right? And all that you have left has an h in it, in the numerator. It always happens this way. And then you're going to have some h's that cancel. So we have the limit as h goes to 0 of h parenthesis 12 minus 6h plus h squared all over h. So your h's cancel. When you plug 0 in, you get what? What do you get? Robinson, you want to tell me? What do you get?
12.
There we go. Okay, so when you plug it in, you get 12. Everybody with me? Are y'all okay? Okay, and that is my slope. So that's my m, slope of the tangent line, right? So we just do y minus y1 equals m onto x minus x1. We could make these x naughts if we wanted to be crazy, and why not? Okay, and so then that would be y minus -8 equals 12 onto x minus negative 2. And so it's y plus 8 equals 12x plus 24. So we get y equals 12x plus 16. Okay? So if you were to graph this curve and the original function, which was x cubed, so if we were to graph y equals x cubed, and then the line 12x plus 16, the cubic function is pretty steep in general, and so that slope of 12 is a pretty steep slope. And if you graph that, you'll see that at that point, negative 2, negative 8, which is down here, you can see it. I might want to change the window and make that more, make this like negative 20, maybe it'll look a little better. I don't know. Okay? Problem is, I think when you move it, it doesn't move the other stuff back. Yep. Come on. I'm in a lot of work now. I'll lasso this, move it up.
Can you move all that over then put it in two?
I don't know. Let's see, let me try going over here. Ah.
No, highlight it just like you did a second ago.
Oh, right, and then drag it,
And then drag it over. And then
and then highlight that and drag.
Miss Brooks, we have to go.
Oh, well, you don't want to watch me play with my computer screen? Are you saying that I'm wasting your time? I'm sorry. Gosh, why do you have to go? You just got here.
We're on like pep rally schedule. It's weird. All of our classes get cut short.
Okay, well, have fun this weekend. Maybe you should do some
Oh,
calculus.
thanks.
We have no class on Monday. Do you have school on Monday? No. Hey,
No,
you know,
ma'am.
next week you have a test in here. Wednesday, come with questions over the online homework. You guys should be about done with your homework. I don't know where you're at. I hope you're doing well. It's kind of weird having me for a few minutes every day, or every third day or something, every other day. Okay, goodbye. Have fun with your football. It's all about you and your football. Football is my life. If it weren't for football, I would not play football on the football field. Does anybody in there play football? They're already gone. Maybe that one guy looked like he had a jersey on. Pardon?
figure what class this is.
Did I forget what class it was?
Time for football.
There's no time. Yeah. It wears you out. Football wears you out, and you wouldn't be able to come home and study calculus, I don't think. I don't know. All right.
I think the highest I took in was football, guy or whatever. I think the highest level of math I took was, I think, pre-algebra.
Were you in football? Yeah.
Yeah, I took the easiest way.
Well, my son made the tennis team, and the coach really said to us and to him, he's like, you can take that pre-AP stuff, but it's really just going to make your life miserable, I said, well, okay. He's not exactly a tennis star, but he's doing pretty good in some of his schoolwork. I don't know. I think those pre-AP teachers are pretty good. I mean, they're just like really good coaches. So you don't necessarily want to miss out on that experience in high school. So. But you do. I mean, his coach was saying you have to make a choice. I kind of wish at the collegiate level they would just sell out and say, okay, look, you're an awesome football player, and we want to use your body to make money for the next 4 years. And then you can come back and study. You know what I mean? Because what ends up happening is they try to do both, and it's hard, very hard for the athlete to try and be the best top-notch student that they can and the best athlete they
They
can.
find them good tutors.
Well, but right. I mean, the kids get through, but did they get the college experience that someone who wasn't asking that much of their body got? Probably not, you know. So it would be kind of cool if they would just, you know, you could do different, like there's a time for everything sort of thing. I don't know. Okay, number 8 says, what are the interpretations of the difference quotient of f at x naught with increment h? Okay, so this is in your textbook, page 135. And so you do have a book, you know, if you click on entire textbook, you can get to the section and then you can scroll through. Okay, so I'll just write some stuff for you. If the limit exists, then that limit is called are y'all ready? The derivative, big word, derivative of f at x naught. So that's very exciting. We have this new word, the derivative. The derivative and the integral is what calculus is about. Okay, so you've got the derivative and the integral. The derivative gives the slope of the curve and if you know the slope of the curve, you can then compute the tangent line at the point x naught, f of x naught. Okay? This is thought of or described to be the instantaneous rate of change. Oh, well, you know, you like the way I spell that? I can't really spell instant. It's got a lot of T's and A's and N's. Instantaneous rate of change, like that better? Of the curve at the point x naught, f of x naught. Okay? And this is big. Okay, one of the big ideas. There's two big ideas in calculus for first year calculus, or pretty much calculus, which is derivative and integral. You do it, you undo it. We're going to learn how to find the derivative, and then we're going to learn how to, once we have the derivative, how to get back to the original function. And just like division's a lot harder than multiplication, integration is much harder than differentiation. So what you're going to learn for the first half or so of the semester, while it's algebraically perhaps challenging, you can get it. It's just you have to practice it, but you can get it. But integration, actually, there a lot of times, I mean, there's whole courses. I mean, you've heard of differential equations, right? Diff-EQ and partial differential equations and ordinary differential equations. I just listed 3 courses on trying to get back to the original function if you have the derivative. So it's much more of a challenge and interesting, but challenging than finding the derivative if you have the function finding its derivative. Okay, so now what am I doing? I'm summarizing. Why am I summarizing the concepts of the section? All right. Okay, summarize the concepts of the section. All right, well, the limit, just write this over and over, or put it on your Facebook, call your friends. The limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. Just live it, be it, feel it, write it 100 times, okay, because it's very important. It has 4 ideas. It is the slope of y equals f of x at x naught. the slope of the tangent line to the curve. It's also the slope of the tangent line. So see, it's that must be somewhat strange to you to think that a curve has a slope, right? We're not talking about a line. I mean, we could talk about line, it's boring, but now I'm giving you like a parabola, and if you take that limit at a particular point, you have found the slope at that particular point, but only at that point, because a parabola, changes. Oh, y'all came back.
Yeah, we were mistaken about the time.
Oh, yeah. I think that one plays football. You must play football. Yeah. All right. We were wondering if anybody played football in your group. Okay.
I think it's just me.
What's your name?
David?
David, how many football players are there?
A lot.
Like 37 on varsity?
No, in your class, in this class right now.
Oh, just me.
All right, and then do we have band?
I'm not in band.
What are the rest of y'all? And the rest of y'all, do you do anything?
I play volleyball. I play
Volleyball, cross country.
Cross country.
You're after my own heart there, cross country.
I run a
Zach, baby.
444 mile.
You would do what?
I run a 444 mile.
Who does?
I do.
He's not on the screen. Come on.
That's pretty impressive. That's very impressive.
Thank you.
I've got a 2:59 marathon.
Ooh, nice.
Yeah.
That's still good. Under 4 hours. Nice.
Pardon? Yeah.
Yeah. Under 4
You're
hours.
looking at an elite female right here.
What's that?
Or at least I will be in September. They're paying my way to run. God, I hope I can break 3 hours again. Okay.
Where are you at?
What?
Where are you running at?
In Moline, Illinois, the Quad Cities Marathon. We'll see.
There you go.
We'll see how it goes. I don't know. They paid money and they said they'd pay my way, so I'm like, okay. I don't make much in this teaching job, so I'm trying to see if I can't run for money. Just kidding. It's a little goal. I have a little dream. Okay. Is the slope of y equals f of x at x naught? Okay, so that's that. It is also the slope of the tangent line to the curve y equals f of x at x naught. Okay, so we've got, it is the slope of the curve at that instant. It's the slope of the tangent line. We also sometimes use the word instantaneous rate of change. It is the instantaneous rate of change of f of x at x equals x naught. And it is the derivative of f at x equals x naught. So you will hear the words slope of the tangent line, slope, instantaneous rate of change, derivative, and always know that that is the limit as h goes to 0 of f of x naught plus h minus f of x naught divided by h, okay? Now, in the next chapter, you will learn shortcuts to find it. But if you were ever asked to prove what is the derivative, you can always go back to this equation. It's not always easy, but it is always the truth, all right? So it's a beautiful moment because you started in Algebra 1 looking at slope. And all we are doing here is looking, I mean, that difference quotient and then the limit is just slope, right? But we're letting the difference between our points get so small that you can't tell them apart. That's where the limit h goes to 0 thing. Okay, so let's do some tricky ones. Find the slope of the function g of x equals x over x minus 2 at the point 3, 3. Then find an equation for the tangent line to the graph there. Okay, so you read an equation like that, you totally know that we need to find the derivative. We don't have the shortcut, so we will have to use our definition. So we need to find g of x naught. Fortunately, they told us the point x naught and y naught. if you put 3 in here, you do in fact get 3. So g of x naught means g of 3, which is exactly 3. G of x naught plus h is g of 3 plus h, which in this case will be 3 plus h over 3 plus h minus 2, or 3 plus h over 1 plus h. Right? Okay, and then we write our formula. We cry for a minute because we see a fraction, but we're okay because you have me. The limit as h goes to 0 of g of x naught plus h minus g of x naught all over h. I mean, I need to see this in some Facebook. I should get back on Facebook. I got off it because I was spending too much time on it. But it'd be fun if my calculus students became my friends and talked to me about the difference quotient. Then it would be useful. All right, so g of x naught plus h is actually 3 plus h over 1 plus h minus g of x naught, which is 3. All of that is over h. Do not cry. You can handle the algebra. All right? In the numerator, you have a fraction minus a number, so you need to get a common denominator. What will your common denominator be? Good, 1 plus h. So you will multiply 1 plus h over 1 plus h here, just multiplying by 1, in order to get a common denominator. And so then in the numerator, or just continue with the limit, we have the limit as h goes to 0 of 3 plus h minus 3 onto 1 plus h, and that's all going to be over our common denominator of 1 plus h, and that's all over h. But we're okay. We can handle this. This is the limit as h goes to 0 of 3 plus h minus 3h all over 1 plus h. Now, dividing by this h, isn't that the same as multiplying by 1 over h? Is everybody okay with that? So I'm going to say that's the same as multiplying by 1 over h. It just feels better. Okay, and so then this is the limit as h goes to 0. The 3's cancel. We have an h take away 3h, so that's minus 2h. So this is minus 2h over 1 plus h times 1 over h. Now remember, the whole idea of a limit is to eventually, hopefully, plug it in, right? And we can plug it in and not get 0 over 0 now that we cancel these h's. We get, and the limit as h goes to 0 is going to be negative 2 over 1 plus 0, which is negative 2. And that is the slope. That's the first part of the question. And then the equation of the tangent line is just y minus y1, which is 3, equals negative 2 over x minus 3. So this is y equals negative 2x. Let's see, that's 6. Move over the 3, so that's plus 9. Negative 2x plus 9. Fun? All right, number 11. Let's ask a different question. At what points does the graph of the function yada have a horizontal tangent line? Okay, what do we know about the slope of a horizontal line?
0.
Okay, so the question they're asking us now is, where is the point where if I did all this limit stuff, I would get it equal to 0? Does that make sense? So we have to kind of figure out, so we know a line is horizontal if its slope is 0. The slope equals 0. So that means we're going to need to solve the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h equals 0. We're going to need to solve that. We're going to need to figure out when does f of x naught, for what value of x naught does that work. So won't that be fun? All right, yes, we have f of x naught. It is specifically x naught squared plus 4x naught minus 1. We have f of x naught plus h. It will be x naught plus h squared plus 4 times x naught plus h minus 1. So this will clean up as x naught squared plus 2x naught h plus h squared plus 4x naught plus 4h minus 1. Y'all okay? Are you scared? Too many x naughts? All right, so then our formula, the limit as h goes to 0 of f of x naught plus h minus f of x naught over h is going to be this, x naught squared plus 2x naught h plus h squared plus 4x naught plus 4h minus 1 minus f of x naught, which is x squared plus 4x naught minus 1 all over h. Aren't you glad you came back, Robinson? Didn't want to miss that. All right, now, what are we going to do? Hopefully, oops, I got an x naught right here. Now remember, don't fear. If you did this correctly, what should happen? Everything that doesn't have an h in it better go away from the numerator, because the whole idea is to get the h to cancel so you don't have 0 over 0. So if your algebra is right, then this should clean up pretty nicely. X squared, x naught squared is gone. 4x naught minus 4x naught, you're gone. Negative 1 minus negative 1, you're gone. All that's left has an h in it, right? So we did this really well. So this is the limit as h goes to 0 of h parenthesis 2x naught plus h plus 4 all over h. Do y'all agree? So I just factored h out of each piece in the numerator that was left. Now I cancel the h's, and when I do a plug-in, I get 2x naught plus 4. What is that?
That's what 0 is.
That is my slope of my tangent line. And now if I set that equal to 0, I will be able to find out where the tangent line is horizontal. So I will set this equal to 0. This is the slope. So I set it equal to 0 and solve. So I get 2x naught plus 4 equals 0. So I get x naught equals negative 2. And how would I get the y coordinate? Well, then I will find f of x naught, which will be the y coordinate, which will be f of negative 2, which is going to be back into the original function, which was x squared plus 4x minus 1. So negative 2 squared plus 4 times negative 2 minus 1, which is 4, and negative 8 and negative 1, which is negative 5. So the point, negative 2, negative 5, is where the tangent line is horizontal. All right? Okay. So, $1,000,000 question. What else is cool about the point negative 2, negative 5 on the graph? Well, let's see. If I graph that function, what was the function? X squared plus 4x minus 1. What do I notice?
Oh, let's see.
It is the vertex, right? Negative 2, negative 5 is exactly the vertex. So not very exciting for a parabola, because you knew how to find the vertex of a parabola. Remember negative b over 2a and f of negative b over 2a? You remember you learned that in some class. But if it were a cubic, it's pretty exciting to be able to figure out where the maximum is. You never knew how to do that, or where the minimum was, if it exists. Okay? Let's see if I can get it to work. Maybe. Let's see. Where did it put it? Oh, put it way down there. Come on. Okay. And so we can draw on this now. This is fun. This right there is the point -2, -5. Okay. Find the equations of all lines having a slope of -1 that are tangent to the curve y equals 1 over x minus 1. Okay. God, I have a bunch to do. I wonder if I should do that. I only have 15 minutes. What should I do? I'm actually going to do, these are on the video. I think, do you want me to do, I don't think I'm going to do this one. It would be the same, except that you're going to set it equal to -1. Okay? And it's yucky because you got to do some of that common denominator action, but I think you could handle it. Okay, so let me move on to the next one. Number something. This one's fun. An object is dropped from the top of a 100-meter high tower. Its height above the ground after t seconds is that. How fast is it falling 2 seconds after it's dropped? How fast, they're asking for its rate of change. Okay, they're asking for its instantaneous rate of change. So they're looking for the slope when x equals 2. Or t, in this case, t equals 2. So looking for the slope when t equals 2. So we know that h of t is equal to h of 2, which will be 100 minus 4.9 times t squared. 2 squared in this case. Anybody have a calculator right there? Let's see. So that's 100 minus 4.9 times 2 squared, which is 80.4. Then we also need h of, this is weird, t plus h, which is going to be h of t plus 2. This is a different h because I'm doing the limit as h goes to 0. Are y'all okay with that? And so then this is going to be 100 minus 4.9 times t.
Miss Brooks, we gotta go now.
Okay, see you later. All right, and so then this is going to be 100 minus 4.9 times t squared plus 4t plus 4, which is 100 minus 4.9 t squared minus, can y'all help me? What is it? 19.6. And then plus another 9, or minus another, what is that? That'll be minus. This will be minus also. Minus 19.6?
Yeah.
Okay. And so then what we're going to do is we're going to look. Oh, I see I screwed that up. That should be 2 plus h. It doesn't really matter, but notation will get you every time. So this is 2 plus h. So this is 4 plus 4h plus h squared. So these should be h's. It's confusing because of the... So I didn't do that right anyway. 4.9 times 4, what was it, 19 point, God, I screwed this all up.
4.9 times 4 is 19.6.
19.6 minus 19.6 h minus 4.9 h squared. Do y'all agree? I'm rushing, I'm sorry. I'm trying in my head to think. I know they use a different letter, and I can't remember what letter they use when you're in this thing. Because h of t is typically how you describe it. I think they may use an a or something. I don't know, the limit as a goes to 0. Okay, so this is the limit as h goes to 0 of f of h of t, which is h of t plus h, or h of 2 plus h, which is going to be 100 minus 19.6 minus 19.6 h minus 4.9 h squared minus 80.4, all divided by h. So we're hoping that 100 minus 19.6 is 80.4, which I think it is, right? Y'all with me?
Yeah.
So this cancels with that, and all that you have left has an h's in the numerator. So this is the limit as h goes to 0 of h parenthesis negative 19.6 minus 4.9 h over h. When the h's cancel and you take the limit as h goes to 0, this will just be 0. So we'll do a plug-in. We get negative 19.6 minus 4.9 times 0, which is just negative 19.6. So at the instant that it's 2 seconds after it's dropped, it's falling at a rate of 19.6 meters per second. And I said falling, that's why I didn't say the negative. Does that make sense? The negative indicates that it's going down. Okay? A vertical tangent is, I can draw some examples. In the function f of x equals the square root of x, you actually have a vertical tangent right at x equals 0. Because you can see what happens to the slopes of the tangents is they start to get steeper and steeper, right? And so right at this instant, you have a vertical tangent at x equals 0. You have a vertical tangent. So your limit is going to be infinite. Your slope is going to be infinite. So your limit is infinite there. So you can't get the derivative at that point. Other functions that have vertical tangents sometimes look like they're kind of like S's, and they just get really, 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 really steep. Just really steep. And so you can say that they have a vertical tangent there. It's not necessarily a cubic function. It's a little bit different function. Anywhere that the graph just gets super, super almost straight, and then it might back off. So right there, wherever it goes vertical, that's a vertical tangent. Okay, so if you graph the curve y equals x to the 2/5, and it says where does the graph appear to have a vertical tangent, let's try that. So we'll graph it with our calculator. X, when you do the exponent, you have to put it in parentheses, 2/5. And then we'll graph. And I'm going to do zoom 4. And you can see this is like the little bird function. No, don't start with your, uh-oh. I may have stressed it out. Sometimes it gets stressed out. Looks like you know how people draw the little seagulls? Okay. Yeah, at 0, it appears that we have, what you do is you see, as you're coming in, do you see how it looks like you're getting more and more steep? Yeah? And so it appears to have a vertical tangent at x equals 0, right? And the way that you can confirm that is to look at the limit as h goes to 0 of f of x naught plus h, so 0 plus h minus f at 0 all over h. So that would be f at 0 plus h is going to be h to the 2/5 minus f at 0 is just going to be 0, right? All over h. And this limit as h goes to 0, h to the 2/5 over h, what is that? Remember when you have the bases are the same and you're dividing, you subtract the exponents. So you've got 2/5 over just, where did the 5th come from? Is that what you're wondering? Because I was being crazy. You got 2/5 minus 1. My head was saying 5/5. That's my excuse. So I was thinking that this is like 5/5. 2/5 minus 5/5, which is 3/5 in the denominator, right? So, or negative 3/5, which is the limit as h goes to 0 of 1 over h to the 3/5. Right? Okay, well, what is that limit? Think about it. As h goes to 0, you're going to get, like, think of going to 0, right? Like 1/10, 1/100th, 1,000th, 1/10,000th. Even though you take the 3/5 of 1/10,000th, it's going to be very, very small, right? And then you're going to flip it. Okay, so 1 over 1/10 is 10. 1 over 1,000th is 1,000. 1 over 1,000,000th is 1,000,000, right? So this, as h goes to 0, this goes to infinity. It's getting steeper and steeper. So that's the limit doesn't exist, and this is the indication. You can see that the slopes are getting steeper and steeper until they're eventually vertical. Does that make sense? So you have trouble with your limit. You don't get a pretty limit. I mean, it's pretty in its own way, but it's not like a numerical. You can't hold on to it. So that's called, which confirms we have a vertical tangent at 0. So you will have a vertical tangent. You can have a vertical tangent when your limit is infinite. If your limit doesn't exist, then that kind of tells you that that the graph goes vertical at that point. Okay? All right, so I got through most of it. The couple that I didn't do, you can check on another video, or it's just more of the same. You can always hit that, show me an example. All right, so that's it.